current per second. It's something that, I don't know, for me it feels more relatable than voltage, just because the speed of something or the velocity of something is something that we use more frequently, I think. Resistance is something that prevents the flow of charge. Resistance is measured in ohms, and it's a little horseshoey guy, three-letter.
Horseshoey guy?
Mm-hmm. So resistance is like friction. You guys have dealt with friction, with air resistance, and now with resistance in the circuit. Now, what do friction and air resistance turn the energy that we're using for something into?
Heat.
Heat. So resistance in the circuit is, it impedes the flow of charge, and it turns energy converted to heat.
So my back has a lot of energy right now? Is that what you're saying?
If you were a circuit, which people kind of are, in their way, I suppose. Oh, no, that would just be radiant heat. But we can use this to produce things like light bulbs, give off light, stove burners that give off heat, right? If you just put a massive resistor, you make a toaster oven. It heats up. You can use that to produce heat from electricity. If resistance is bigger, you'll get a brighter bulb or a hotter heating element. But resistance is kind of like the friction in a circuit. So let's talk a little bit about a real circuit over here. So when you're drawing a circuit, you have a battery. This is the symbol for battery.
That just seems like a good idea.
The little
Looks a
squiggle.
lot like an 11.
Beautiful.
You have a long side, the short side, little squiggle here. The little squiggle is a resistor. That could be a light bulb, a heating element, or whatever else you want your circuit to do. So what if I have a 6-volt battery here? So 6-volt potential difference. And I have a 2-ohm resistor, maybe a light bulb or something. 2-ohm resistor. So can you use Ohm's law to find the current in the circuit?
Potentially.
Potentially. And what would that current be? So Ohm's law is V equals IR, where I is the current that we're trying to solve for.
So 3. Could you do me a favor?
So
and
3.
For the resistance for it.
Who?
Thank you.
Come on, focusing in for Paul.
Okay, so current I is going to be 3. What's our unit?
Voltage.
Amps. So 3 amps. So a volt divided by an ohm is an amp. We'll look at that in a minute.
Horseshoey thing.
Horseshoey thing is an ohm.
That's an omega, isn't it?
Okay, so
Why are we bringing omegas into this?
what if we added another resistor? Or maybe I'll just draw a whole different.
So you're gonna make everybody motion sick. We're gonna watch this and just be like, Clay, why are you doing this?
So if I look at this circuit, let's say I got a 12-volt battery, that same 2-ohm resistor, but then I add a 4-ohm resistor.
1. No, it's still 3.
Well, then you have to consider.
Why are you saying ohm?
That's the measurement of, that's the
resistance.
So is
unit
it
unit.
not an omega?
It's the piece of resistance.
It is, but you would say ohm.
See, omega.
I know, but why would I want to say omega.
It's named for a scientist whose last name was ohm.
Oh, I know
Ohm's
as well.
law. So if we have this circuit, you can see that those two resistors are in series. Okay, current to flow through the circuit has to flow through one and then the other. There's no way for current to flow where it can skip one of those. So if you have these, or light bulbs, for example, and one burns out, that breaks the connection, opens the circuit, and current can't flow at all. Right? Current has to flow through both of those. That's a series circuit. If you have a series circuit, it's pretty straightforward to figure out the total resistance of the circuit. You just add them up. So if I've got these two resistors and they're in series, the total resistance of the circuit is going to be 6 ohms. So what will the current be?
2.
So
2 amps.
current equals good, 2 amps. I think they usually capitalize the A. I'm not that careful. But anyhow, so in a series circuit like this, charge has to flow through each resistor. We'll learn about parallel in a minute. That's not the key. So which of the two bulbs in that circuit would light up first?
I'm going to go against everybody and go 4.
Wait, does it go clockwise or counterclockwise?
Which one's
So
positive?
here's
Which
the
one's
thing.
negative?
Yeah, which one's positive?
And see, I actually did not know this until last
What
week.
came first, the chicken or the egg?
Well, I
The
just learned
chicken.
this. So we talked about electric
egg.
fields last week, the week before, right? Electric fields.
Chicken.
So the electric
Why would God make
field,
an egg?
listen, the electric field that's
Eat.
generated
Chicken.
when you connect this circuit travels at the speed of light, and the field spreads in every direction at once. And so the electric field affects both light bulbs at once, so they light up simultaneously. And
What?
yes, isn't that interesting? I did not know that.
So
Are
it
you
was
sure
a
it's
trick
not
question,
just
and it
the
was
current
both.
is moving so fast we can't detect any difference between them?
No, because think of a hose full of water, right?
Okay.
And then you turn on the flow, but the hose is already full. What part of the hose starts moving
Closest to the
All
faucet.
of it.
first? All of it. Because
Because we got the flow going.
Because there's already stuff
It's
in
already
it,
got
so,
that
like,
flow.
So
So-
it's kind of like whenever you have like a car in front of you and you just like push it a little bit and it starts like, the whole thing moves, not just the...
You push the car.
You push the car in front of you.
I do. And whenever it's a green light, he's not going!
so voltage
He's like,
is
bump.
like
No.
water pressure, right? We turn on that pressure. If
In
the
your
whole hose is
Prius.
already
It's
full
a
of
cannon,
water,
right?
I lied.
similarly, a circuit is made of metal. It's already full of the electrons that are going to flow, right? So as soon as that electric field spreads out at the speed of light in every direction, the electrons start to move, and they're already there. It's not like the battery has to shoot electrons to fill up the circuit. The electrons are already present, right?
Clay, what are you
So you
doing
just
with your
grab
leg?
pressure.
I'm determined to make somebody throw up.
No.
Who watches
No,
this
this is how
video.
you throw it to me.
Oh my goodness.
Ooh!
No.
Oh, come on! I was gonna film.
Goodness gracious.
Sam! Pass me the rock, bro.
Bad decision. You pay attention. So,
What do I do?
where am I? Current flows simultaneously through the whole circuit because the field causes the flow, and the electrons are already present. So, you guys know that electrons share characteristics with light in that they behave partly like a wave and partly like a particle, yes?
Oh,
There's a wave-particle duality to light and to electrons, but electrons have mass and light doesn't. But they both still have wave-particle duality. So, you guys know that electrons move really, really fast, but electrons don't necessarily move in a straight line. So only part of their velocity vector is pointed in the direction the circuit's flowing. So like, if you guys think of walking down the hall, focus, Eric.
I'm
Think
focused.
of walking down the hall, you're going along down the hall, right? But,
You're drunk, so you're just going all over the
so
place.
an electron is like that, someone who's dizzy or something and bouncing
I like how
around,
you went wrong. She went dizzy or something.
dizzy or something.
Well,
So the electron,
She's a teacher, she can't
all
do
of
that.
its velocity is not directed in the same direction as velocity is doing this. So it wastes a lot of time moving around like that. So electrons
it's like a
move
woman
in the
trying to-
direction of the circuit kind of slowly. Kind of slowly.
We don't
Compared
care.
to what you might think. All right. So in a series circuit, like these guys on the board, where the flow of the current has to pass through every single resistor to go through the circuit, then current is constant at every point in the circuit. Current is constant. Okay? In the top one there, current is 2 amps everywhere, and the bottom one there, 3 amps everywhere. Okay? So, let's do this and add in.
Why do you wear that hat? Get rid of this.
Because I'm trying to attract women. What do you think?
Oh, there are.
it's
I
not
know.
working at all.
I know.
So what if I add another resistor?
We'll see you.
Dude, we got canceled because of a bomb threat.
What if I add another resistor into this circuit? What
Literally,
would
they
my
sent everybody home
current
like an hour
be?
early.
Because
of a stupid bomb threat.
4. No. 6.
I'll go up in flames. Let's keep
Okay,
going.
one.
It It'll be 1.
Yep, my current's
so
going to
glad.
become 1.
Exactly.
Pay attention, you got to hang with
I'll be
this.
raving as I burn into a
Daniel, stop.
Sorry.
All
No,
right,
you're not.
so now we've got a new circuit up here. It's a parallel circuit with 2 resistors, a 6-volt battery. Current will be constant in a circuit that has all series connections.
Delicious.
So current is going to be 1 amp in this. So what would the voltage across each bulb be? Voltage does not necessarily have to be constant, yes? So consider the 2 ohm bulb here, right, for the 2 ohm bulb. So if we apply V equals IR here, right, we want to find the voltage for this bulb. Well, we know current is constant 1 amp. The resistance just of this bulb is 2 ohms. So the voltage just for this is going to be 2 volts. Probably not a surprise. Guess what the voltage over just this bulb is going to be?
6.
Multiplying lamp by 2.
6? Is it 6?
Right. So
It's 6, isn't it?
when you're doing the lab,
24.
the book doesn't talk about this, but when you're actually doing this in the lab, if you test the voltage over the battery, and it's really a 6-volt battery, you should get 6 volts. If you test the voltage by using a voltmeter right over just the 1 bulb, you'll get the voltage of that 1 bulb to be 2. Because current's constant, we can figure that out mathematically. If you test the voltage over just this bulb, it'll be 4. But
We mess around with circuits today.
hopefully, if we get through everything.
Do you have circuits?
I do have circuits. I don't have
I was talking
everything.
like
I just have the
circuits.
beginning of next week's lab with us today.
Yeah, we get those things where you connect all the tracks and you have like the slot cars you put the car on and everything. They're too old for you.
Focus.
I'm
Okay.
the same age as you. I'm like a month younger.
Alrighty,
Wait, not
Eric.
even.
Do
It's
not
September,
make
right?
Paul sick.
Yeah, you're like, well.
Look.
Paul's already
Yeah,
sick,
all
isn't
I'm
he?
saying is younger than you. Chill
All
out.
right. So
Stick the car
let's
on
put in
the
a
track.
third
I understand
resistor.
Yeah.
Actually, let's just pitch all this because it's all written all over.
I had the Hot Wheel tracks, like the orange ones.
Yeah, where you stick it in there at the end and you go down the hill with that thing.
Yeah.
I'm gonna make it longer.
I remember like I used to put like over the house kind of thing, and I would just drop a Hot Wheel, and then we left them in Florida when we moved up here.
Yeah.
Another time.
Aw. Now focus. You with me? Okay.
Wow.
So when we're doing this in the lab, we have just a bunch of little light bulbs. Okay. We're gonna hopefully assume that every little light bulb is like every other little light bulb.
I'm sorry, I actually have a question concerning the other thing. You said if you put the voltage meter on either side of the 2 volt or 2 volt
2 ohm
bulb
bulb.
thing,
2 ohm bulb.
okay,
Because
you
it's
get
resistor.
2
2
volts,
volts,
right?
because current
so
is 1 amp.
if I put one on the side of the 2 ohm bulb and then put the other one on the 4, would I get 6?
You should get 6. Yes.
Okay, just making sure.
Mhm.
I didn't know if there was some like weird stuff, and I'm only going to get 4 or something like that.
And what we're ignoring in the lab, and hopefully next week we'll try to consider it and see if it works, but we're ignoring the resistance of all the wires in the battery. Hopefully compared to the light bulb, the resistance of everything else that makes up the circuit is so small that it's essentially able to be ignored, like air resistance.
Okay.
Are we
But
gonna
we
go
don't know
next
that.
week?
Why?
This,
I don't know.
this week you're going to have half of 15, next week we'll have lab for 15, we'll do 16 in 1 week, and then a review for the final. So you will
And
have,
review.
Is the final in
Yeah,
class or
16.
at home?
final go home.
Okay.
You can have then, so you'll come 1 more week for 15, 1 week for 16, and 1 week for review for the final, so come 3 more times.
So that means there's an extra week.
Because I only have
Yeah, that is an
2
extra
more
week.
classes in my other class.
Yeah,
Yeah.
come 3 more
I'm so
times.
glad finals week is coming.
True.
You're so glad, did you just say that?
Yes.
Okay.
I'm glad.
Because that
When
means
it's
it's
done,
over.
Okay.
It also means I'm going to have a heart attack
So-
and maybe a stress, like
True.
Listen,
anxiety attack.
Eric, so let's
Hi.
assume that this is what we'd be doing in lab, and all 3 of those little bulbs are exactly the same. So let's say also that we're using a 6-volt battery. We don't have a 6-volt battery today, but
What do we have?
we'll have to test and see, depending on how
So you
dead
really
or
don't
alive
know,
batteries are.
and we have to do this mathematically? We're relying
It's
on my
a
math skills
lab.
now?
Oh, goodness.
It's a lab. You just take the voltmeter and see what your battery's reading today, because maybe, and you have to test it several times because the battery gets used up through the experiment. The voltage will change based on it being used up.
Can we
My
like
dad.
go outside?
Do what?
Sit outside and do class.
Do what?
That would
Yeah.
be
There's
good.
not a whiteboard outside.
Yeah, totally.
We have portable whiteboards.
We can bring the
Like,
plan schedule.
So let's say
The what?
each
Very
of these is going to be a 2 ohm bulb,
That's what it
and
says.
that's not nearly what we're
Okay,
actually going to see in the lab, but we'll just go for that, okay? So
No.
what would the voltage across one bulb be?
2.
2. And what would the voltage across 2 bulbs be?
4.
Okay, so we're all
Six,
together.
8. Who do we
Uh,
Shut up.
But if it's 8, is it still 2 or is it 4? If like you have
Right.
the 8-volt battery.
If
Or
I
is
had
there
an
no
8-volt battery, well then I would have to do it again, where
Oh, never
8
mind.
volts equals, and I'd find current, and then the
Eric,
current
seriously,
would
stop.
remain constant.
Chill.
Because in
Chill.
a series circuit, current's
Chill.
constant. So I just have to recalculate.
There'd be no Japanese waters.
So here's a thought question. Will the battery last longer
Chill.
if I have more bulbs attached to it or fewer bulbs attached to it?
If you have more bulbs, it'd be less amp, right? Because it's on the bottom, so it makes the numbers smaller.
Right, so if I add more and more bulbs, what happens to my battery life?
It dies faster. What's the
It
question?
lasts
here?
longer
Sorry.
because it's used.
I thought you asked what happens when you have more bulbs, and I said you get less amplitude. Or amps, whatever amp stands for. Is it amplitude? What is it? Is it
Ampere.
abdominals? What is this?
Ampere.
Abdominal?
Abdominals?
Abdominals.
That's because whenever I do crunches, my abs go.
No.
So battery life is actually longer with more resistors in the circuit when you have a series circuit. We haven't talked
Yeah,
about
remember
parallel
this
yet.
last history I need only one more English. I'm
So
doing
let's
communication
consider it,
policy.
right? Consider how many amps this battery has. So 6 volts
I'm
equals
not ditching you.
I times 6.
Oh, you're just going to CSM?
I'm going to
I'm not going to do that.
Okay.
I can't afford that.
I'm actually starting next year, so technically I'm graduating high
Hey
school.
guys,
Yes.
really try hard to pay attention for just a little bit so we actually get to do a lab, okay?
Okay.
All right, so I'll go for the light blue here. What if I added, just to kind of examine this, what if this is still in series, I added another resistor, what would happen?
It would
So-
die.
Slower, right?
See, look at all these nice notes.
What nice notes.
It's on paper.
Beautiful.
Okay,
Goodbye. How
so
you going to kill it?
look what happens to the current as I add bulbs.
Just Daniel.
Current is 1 amp with
Mom,
3
you love me.
bulbs, but current
I
with
love
this
you
4th
guys. I
bulb
don't know
decreases.
that.
Decreasing current means the battery will live longer. That's only true for the series circuit, not for the parallel. So,
There you
Okay.
go.
so now we need to talk about the parallel circuit.
Do we need to talk about it?
Have we got a good view of that side of the board?
We have a very good view
I'm
of
gonna talk
all.
about it.
It's not zooming in.
I don't care.
We've only got 10 minutes left of videoing.
Oh no.
That's what it says.
No. Okay.
Do we have more batteries?
These videos.
No,
I
it's
have
not batteries,
batteries
it's space.
Oh yeah.
I got
we
batteries
have,
on charger.
We have batteries.
We got
Today
that.
we should have
We got
batteries, right?
fat stacks of
All right,
bats.
so let's look at another kind of circuit called a parallel circuit. And I should draw it like a smart person.
I really hope one of like the chemistry kids just watches it just for fun. This would be hilarious.
It would be.
Why would that
They-
be hilarious?
Because we're
Really? Is that a question?
We are. Right.
I don't want them to learn any. Eric, please. All right, so
360 life.
let's go kind
Too
of
strong.
with
What in the
the
world?
way we started out.
I got this.
What are you doing to this core?
What am I doing?
That's an excellent question.
We'll kind of compare two circuits here.
What am I doing?
So this is a parallel circuit, and this is the similar series circuit.
Are you trying to kill me?
Yes. Did you
Can
finally?
someone give me a battery, some voltage, so I can like
My mom, okay, so my mom licked my uncle told my mom to lick a 9-volt battery.
Recently, or like,
No, a while ago, and he's so serious. My
It hurts.
uncle is so serious. He's like the most serious person that wouldn't do something like that. So my mom, of course, trusted him. I don't know why he told her to do it. So she trusted him because he's like never joking around. And she looks at the battery and goes like, "Well, she."
I did that. One of my
That was
physics
before I was
students
born.
was like, just lick it won't hurt you, and I did. I don't trust you guys.
and then the rest of the class, you're sitting there going, "Okay, guys,
It
well."
wasn't that bad, really. But
You turn into Jar Jar Binks.
it was surprising. So let's consider this parallel circuit, right? So if we think of current as like flowing instead of the electric field is flowing, okay, so we kind of maybe aren't going for the whole truth here, but let's say current flows out. Now it gets to this little fork in the road, right? Is current going to go, like, is each electron going to say, half of me can go this way and half of me can go this way?
No.
No. So current has to choose. It can go that way or it can go this way. And it does actually have to choose a path.
Isn't it easier to just go straight because the flow is pushing it?
No, because if the straight way gets more crowded, you want to take the side road. So they really do literally divide in half.
But not by mutual decision, by force.
Yes.
Yeah, just like
So
water
it's kinda
would
like-
naturally
it's kinda
divide
like-
in half.
Driving down the highway and you
Given
see an
the-
accident,
it's kinda-
so you take the side road.
It's kind
Yes,
of, it's
that.
kind of like whenever, like, when I'm at work and people keep walking in, they pick registers based on who the faster
Yes.
line.
Yes, like the cash register
Which is
thing
always
is a
fine.
really good way to think of the parallel circuit. So is there going to be a longer line when there are more registers open or fewer registers open?
Maybe a longer line, fewer.
Okay, so if you think of the longer line,
Depends how fast your cashiers are.
Which, if it's like me,
I know my boss
pretty
can run one register faster than our two you guys.
All right, well, assuming that our bulbs are identical or our wafers
suck.
are identical,
Always.
Or our old guys been working there.
focus. So longer line is analogous to resistance, right? So
What?
if I provide two lines
Longer
instead
line
of
is equal
one,
to resistance.
what will happen to resistance if they have a choice to go this way or that way?
Can you say it again?
Resistance would change depending on which path they take, correct?
Yeah. What? Is that foil?
No, it's not. It's paper.
Gum
It's
wrapper.
Burning it, so.
It is foil. Oh,
It's
Eric, don't
muffin.
kill
No,
my
it's
battery.
I'm not killing your battery!
Killing my battery, and it smells minty. Very minty over there. Okay, so I already boiled the cabbage. It's gross.
Why is this not
So
working anymore?
when you provide multiple
Or
cash
It is.
registers or multiple roads that people can take, you decrease resistance. So every single time I add a light bulb, I decrease resistance. This is like the crazy truth of the parallel circuit. Resistance decreases.
Is this the kind of stuff electricians do?
They do much more complicated stuff than this, but they
I'm
should
not
be able to know
gonna
this.
be a
Really?
What is that little swastika thing?
swastika. That's not a swastika.
It looks
Where?
like it.
That is not a. That's like
Oh,
a double
is that
S.
is that a,
That's the bacon symbol, which means approximately.
Or analogous to, kind of.
It's
Yeah,
she
I call
did.
it
It's
the
just very bad. It's not like this squiggly like it's supposed to.
That's not even, no, it's not even a swastika. What are you?
Yeah, really.
Yeah,
Abby's got
You
like.
want to confess, Abby?
Yeah, really.
I don't know.
Abby, are you part
Okay.
of SS?
So,
Are you sure?
I did
tell
not
me
see that
about
coming.
tell me about overall current when it leaves the battery here.
It's down.
Well, actually, you can't know that yet because V equals IR.
So does
So,
it?
Really?
all right. So I'll tell you how to deal with resistance
If
in
it-
the parallel
Riveting.
circuit. In the series circuit, you just add them up
It's IR.
and you say
RIP.
these two are just like having a 4 ohm resistor. But what do you do? Does anyone read the chapter? What do you do in the parallel circuit to add two resistors that are in parallel with each other?
Multiply them.
No.
Divide them. Subtract.
So there's
Make
an
them love each other.
equation. You have to use this equation.
I hope not.
1 over resistance total
Talk
equals
about hugging,
the
weirdo.
inverse of every resistance.
He's like.
So we have two
I'm so
resistors, so we do both of them.
Me too.
And you do them like this. So everyone calculate the
Pray for
total
us.
resistance. You're not solving for 1 over R, you're solving for R total here with a calculator now.
El total.
I don't know where my calculator is, so while I find it, solve it.
That's nasty. Alright. 2 over 2 ohms.
Wouldn't that be 1/4?
No, it would be
1 over.
Yeah, 1/2.
No.
it would be 2 over 2 ohms.
Yeah.
2 over 2 ohms. But are we taking the 1 off the R?
Times 1.
Or is it, yeah.
Would we have to do like so just be common denominator?
No.
2
that's
ohms.
already
No, they're
Later.
not through the whole equation.
Yeah, but then
So-
once you get to that, you
It'd just be
multiply
right?
each side by RT.
1 ohm.
What? Why is it 4?
1/2 plus
2 plus
1/2
2 is
is
4.
1.
Yeah.
So
Alright,
be
so what will resistance be? Like if I
1.
flip that one and I flip that one, R would be 1. So if you look at this, right, in this circuit, adding these two resistors
think
gives
it
you a
hurts now.
resistance of 1
I
ohm.
burnt it.
But in this circuit, adding two identical resistors together gives you a resistance of 4 ohms. Parallel and series circuits behave completely different. Okay? If they're in series and one burns out, the circuit is open, right? It's not a closed circuit. It's not a complete circuit. These, I hope your parents all watch
Can you please
this
do some
video.
sort of wildlife narration over here?
And this,
And here we
And-
have.
put
The
your
Daniel
attention here, Eric,
in
and
his
put Paul's attention here.
natural habitat.
Force
Wait.
Paul to pay attention.
The Daniel is smiling.
So, in this one, in series,
Oh, pay attention.
you get 4 ohms of total resistance. In this one, in parallel, you get 1 ohm of total resistance, even though they're the exact same two resistors and the exact same battery and the exact same wires. Just connecting them in parallel versus series is different. Now, if this bulb burned out, would this bulb burn out or stay lit? Stay lit, because now the path only goes one direction. All the electrons have to choose the top path, but they still are able to go from one side of the battery to the other.
Really? No one bless me? I'll bless myself. Bless
you.
me.
I didn't hear you sneeze. If this one burns
She was
out,
too focused.
right,
I'm a
then
bad-
you'd have an open circuit and no current could flow at all. So that's the difference between parallel and series. You have to calculate the resistance differently.
Can you put the camera back, please?
Oh, pay
And-
attention.
You have to
Why
remember
you shaking
that
the camera to me?
they burn out differently.
Should we?
So let me
Paul
put
is
this
just
back.
looking at his